All right, guys, good morning. Thought I'd just say hello real quick and tell you we're going to be graphing cube root functions and square root functions today. I'm going to bounce back between PowerPoint and the Elmo and maybe even Desmos. So hang for just a second. I'm going to get this Elmo on my paper instead of on my face. And yes, I did get a haircut. All right. Okay, so guys, take these notes in your journal. You can use graph paper if you got it. You can do it in your notebook, wherever you want. Okay, so real quick, I'm not sure if you really understand this question because I don't know how much you learned in Algebra 1, but I'm going to answer these three questions. I'm going to take this function, which is a parabola, y equals x squared, or f of x equals x squared, whatever you want to call it, and I'm going to shift it up 3 units. I'm going to shift it left 2 units, and I'm going to reflect it over the x-axis. So I want to go over here to the Elmo and show you what I'm talking about. Let me zoom in. All right, so y equals x squared. This video is probably going to be longer than I want it to be, but I don't think they allow me to go over 15 minutes, so you might get lucky. So y equals x squared. Here's my x and y coordinate. I don't have to get too fancy with it. But y equals x squared is called a parabola. It's not a good one, but it'll work. All I'm going to do, if I want to shift this parabola up 3 units, I'm just going to go 1, 2, 3, and then, I end up with the congruent shape up here. Okay, but what is the equation? If y equals x squared was the original equation, or f of x, which however you want to write it, all I did was, let me make sure I did that right. Yeah, 3 units up. All I got to do is write y equals x squared plus 3. That's the equation. Now, if I want to shift it to the left, let's see. Yeah, 2 units to the left. I'm going to draw another graph right here. Again, I'm going to go back to the original graph. I'm not going to work with the one that I just shifted up 3 units. So again, here's y equals x squared. Again, it's at 0, 0. Its vertex is at 0, 0. And I want to shift it left 3 units. So I want to go 1, 2, 3. And now the vertex is here. And it looks something like that. Well, how do you write that equation? Well, this is the tricky one. Y equals x plus 3 squared. Anytime you shift something left or right, the sign is opposite of what you think it is. So I went left 3, which is usually negative, so I put a plus 3 in there. Back up here, I went up 3. Sorry, I was supposed to go left 2. If I'd have gone left 2, it would have been right here. Sorry. Left 2 would look like this. Okay? But anyway, when you shift in the y direction, the sign is what you think it would be. Up means positive. But when you shift in the horizontal direction, the x direction, the sign is opposite of what you think it would be. This is a left shift, 3 units. This is a left shift of 2 units. Finally, what does the equation look like when you flip it over the x-axis? Well, I'll show you what the graph looks like, and then I'll show you what the equation looks like. Okay, here's the original graph for a third time. Y equals x squared, or f of x, whatever you want to say. And I want to know what the equation is if I just reflect it down like this. Okay, easy, easy. All that is y equals negative x squared, or I don't really need the 1, but just negative 1 times x squared. Guys, this this number in a formula is going to be called A. This number in a formula is going to be called H. That 2 right there. And this number in the formula is going to be called K. So just remember that. K moves the graph up or down. H moves the graph left or right, opposite of the sign. And A reflects it over the x-axis. And A does one other thing. It also stretches or shrinks it. So if I were to make that a -2, that would flip it over the x-axis, and then it would stretch it out and it'll look skinnier because it's being stretched taller. So A does 2 things. It can reflect it over the x-axis, and it can also stretch it or shrink it. If this were a fraction, it would shrink it. So anyway, that's a little bit about A, H, and K, and about transformations. Okay, that was your warm-up. So there you go. We did it together. There. They changed it to g of x. It said f of x right there. They changed it to g of x. Oh, they said they wanted you to change it to g. I see that right there. Okay. See the g? And then reflect it over the x-axis. Okay? All right. Radical graphs. That's what we're learning today. We are 6 minutes in. This is probably going to take 2 videos. Use a table in your calculator. Draw a rough sketch of y equals the square root of x. Okay? So, I'm going to Alt-Tab. I'm going to write y equals the square root of x. And I'm going to do a rough sketch, which means just kind of draw x and y axis again. There's your y axis. There's your x axis. And it says to use a table in your calculator, so here we go. Remember, I hope you guys that have the big calculator, I'll try my best to pull that one up as well. You're supposed to already know how to do this, but you probably forget. So I'm going to go to table. We'll go to edit function. I'm going to type in the square root of x. And then I'm going to hit enter. I want my table to start at 0. I want it to go up by 1, so I'm just going to keep pressing enter. Now I'm going to get my table. I'm going to use 0, 0. I don't use any negative numbers, by the way, because it get error. All right, 4, 2. Let's find one more good point that doesn't have decimals, 9, 3. Okay, so y equals the square root of x looks like this, 0, 0, 1, 1, 4, 2, that's not negative, that's just 1. 4, 2 is going to be about right here. And guys, that parabola that we just graphed, this is half of it turned sideways. The reason that happens is, I'm just going to come over here and show you, y equals x squared is that parabola we graphed in the warm-up. X equals y squared is the inverse function of that, which looks like this. Okay, it's this U-shaped. We did inverses a while back. And then if you solve this by taking the square root, you get y equals plus or minus the square root of x. Well, this down here is y equals negative square root of x, but this part up here is y equals positive square root of x, which is what we're graphing right here. Y equals the positive square root of x. So again, we started with the parabola that we did in the warm-up, then we switched the x and the y to find the inverse of that parabola, and then we solved for a y, and that gave us this branch of the parabola and this branch of the parabola. But then we realized that the graph we want is just the positive part, so that's this up here. So anyway, there you go. That's a rough sketch. All right, let's go back to the PowerPoint. We're at 9 minutes. I know, and you haven't taken many notes. Plot enough ordered pairs to see the shape of the curve. choose only positive values for x. Okay. Here's the points I told you about. Find good points in your table. There it is. I know you can't see the title up here, but that says radical functions. I wish I could make it bigger, but it won't let me. All right. There you go. And there's your graph. Guys, we call this a shoot because it looks like the way a basketball arcs when you shoot it. So anyway, that's the nickname I give for this graph. It's called shoot. All right. Now, we're going to move this up or down or left or right or stretch it or shrink it or flip it over the x-axis. So, oh, by the way, there's the name, shoot, square root, shoot. All right. But before we do any transformations, let's just go to the cube root function. All right. I'm going to go over to Elmo. We're going to graph this. Alt-Tab. Running out of time, I know. So now, what does y equal the cube root of x look like? Okay. So, get my handy-dandy straight edge. Draw x and a y-axis. By the way, this graph can have positive and negative values of x because cube roots can do that. X, y. All right, so I go to my calculator. Try to get it out of the glare. There we go. Go back to table. Go back to edit function. And now I'm going to do 3 and then the blue button and then the X box button so that I get cube root. And then I'm going to type X. And then I'm going to, on this screen, I'm gonna start at 0 again and go up by 1 every time. Oops. Let me try that again. 0, enter, 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 down. So, some of my points are 0, 0, 1, 1, and then my next point is going to be like 8, 2, because cube roots, all these others are decimals, 8, 2. So hopefully I can make 3, 4, 5, 6, 7, 8, 1, 2. So 8, 2. Okay? But now, go backwards to the negatives, because you can do negatives with cube roots. Cube root of negative 1 is negative 1. And the cube root of negative 8 is negative 2. Negative 8, negative 2. So this graph, again, don't try to connect it with straight lines. Curve them. And that's what the cube root function looks like. Okay? We're at 13 minutes. We're running out of time. So let's go back to the PowerPoint. Make a table of values. Choose both negative and positive values for x. Okay? Negative 8, negative 1, 0, 1, and 8. Those are the points I used. Good news. Guys, this graph looks like the arms of somebody who's swimming freestyle. Okay, if you've ever seen a swimmer swim freestyle, looks like that. That's what I just graphed. Mine's pretty good, just about like that. Mine's a little skinnier, but that's because my scale, my graph is a little bit more accurate. Now, this is the complete formula for a square root function. With the a, we're not going to really use the b right here, but we're going to talk about a, h, and k for sure. Okay, write that formula down. We'll probably discuss it more in the next video because I only have 28 seconds left. A reflects it over the x-axis. It also I'm running out of time. Down to 10 seconds. So that tells you all about A. That'll be the end of this video, and I'll do one more hopefully.